Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1876, which is substrings of size 3 with distinct characters. Let's see the problem description. A string is good if there are no repeated characters. Given a string S, return the number of good substrings of length 3 in S. Note that if there are multiple occurrences of the same substring, every occurrence should be counted. A substring is a contiguous sequence of characters in a string. And let's see the constraints. The length of the string will be up to 100 and S consists of lowercase English characters. So let me discuss the algorithm with you. So here I will use sliding window algorithm where the size of the window or length of the window will be 3 because we have to find all good substrings where the length is 3 and good substrings are those who have no repeated characters in the uh, in that substring. Okay, so we have to find the non-repeated, like how many characters are there in the window, like unique characters, and we will check if it is equal to 3 or not because we have to find all unique characters and the window size is 3. So we will check the count of unique characters are 3 or not. If it is 3, then we will increase the count or increase the answer, and then we will return the answer. So let's see how can we do that. So first I will use an unordered map to count the unique characters. The data type will be cat, comma int, input, and we need an answer. Initial is 0, and let's say the window size k equal to 3 here. Okay. Now for the I equal to 0, I less than h dot size, I plus plus. First, we will increase the MP of character, which is s of I plus plus, and then because we have to check it is a sliding window, so we will not check like further computation if the window size is not equal to 3 or not equal to the required window length. So we will check if the window size or I is less than k minus 1. That means k is the length, so less than k minus 1 means the length of the current window is not equal to k. So we will just continue, and otherwise if the length of the window is equal to k, so then we will check if mp dot size. That means mp dot size means the unique character count is equal to k or not, because k is the length of the window and we will need all the characters unique. So we'll check if it is equal to, then we will increase the answer by 1. Okay, and then we have to, in sliding window you have to remove the left side also when the length of the window becomes like the required length. So the index will be, left index will be I minus k. K is the length of the current window minus 1. It will be the left side index, and we will first mp of s of I and d. We will decrease that and also check if it is 0. Mp of s of I and d is equal to 0. If it is 0, we have to remove it because otherwise it will be stored in map with the value of 0. Then the map dot size will be like, if even if it is 0, then also it will the map dot size, it will give like consider it as one unique character, so we do not want that, so we have to remove the character if it is the count of that character becomes 0. So we will map dot erase the character which is s of I and d, and after that, after the for loop, we have to return the answer. That's it. Let's say will it work. So there is an error which is because the left side index will be I minus k plus 1. It is not minus 1. So let's see. It is accepted. Let's submit it. It is accepted. Let me discuss the time and space complexity it will be. So the time complexity, we are traversing the whole string. So the overall time complexity will be big of n, where n is the size or length of the given string. And the space complexity will be big of constant, because we are counting the frequency or counting the count of each character, and we know in English that all the characters could be like lowercase English letters. So the maximum size of another map would be like 26. So we can ignore that. So we can say the overall space complexity will be big of constant, or you can say big of 1. Thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.